Move, please. All right, well, welcome to week 3. I think most of you who needed to probably heard it. Ad codes, I'm pretty sure I'm allowed to give out now, or able to give out, so we'll do that during the break. And so what are we going to do today? So we are going to build a calculator for tips, I guess, so we'll call it tip calculator. And everything we're going to do today kind of supports that work. So we're going to talk about architecture. And so what does that mean in the context of creating a computer program? We're going to talk about how we can build a structure that makes it so that we can work together on a project easily. We can learn from other people's mistakes and just have a common language. So we'll talk a little bit about that. The two types of architectures that we're going to talk about are MVC, which stands for Model View Control. We'll go over that when we get there. And then the other one is MVVM, which stands for Model View Model. And again, we'll write that down properly once we get there. And they're very related. So MVVM can kind of sit on top of MVC, and we'll talk about why they both exist, why one of them has to exist, what benefits that they have, maybe a couple of other architectures that are out there, so we'll talk about all of that. And then the other thing that we'll run into is something called optionals. So we've already seen some weird symbols at the end of some variable types. So we've seen exclamation points. Maybe we've seen some question marks. If you've looked at some code online, maybe you've seen a double question mark. So we'll make sense of all of those. Lots of questions, maybe still, and then hopefully at the end of the class we have an exclamation point. We know what it means. No, just it's a terrible joke. Sorry. All right. So yeah, that's what we're gonna do today. I think so today, normally I like to start with a review, but pretty much everything that we're going to do today, in some sense, is also a review of the last 2 weeks. We're going to apply all of the things that we've kind of covered, and I'll just point out when we see something that might be still new to you that we've covered, we'll just talk about it as we get there. Any questions? Cool. All right. So tip calculator. Let's maybe first decide what it's supposed to look like. So we'll have a way for, so what do we need when we're calculating a tip? So we'll have to have a way for the user to enter an amount. So we're going to see a new component, a new view component that we can use, which is called the text field. And we can have the user type something in, and we can get that information and do something with it. So we'll have a text field, and we're also gonna have a way to. So we won't start with this. We'll kind of add this later. We're gonna have a way to pick a percentage of a tip that we want to give. So maybe at the beginning it says maybe 20%, and it'll use that to calculate our tip. And then a little bit later we're going to see another view component which lets us pick the tip. So if we tap on that, we'll get some options for what to display. It's a little like downward. I think they're called carrots. So we'll see all of the options that we can pick from. In this app, we won't have an option for the user to manually type in a tip. We'll just have some pre-selected options that will allow the user to pick. And then we'll have a button, maybe let's say calculate. And then here we'll have, so maybe tip. We'll have a label or text that allows us to then display. So maybe if someone types in $100, here we'll have $20 displayed. So that's what we're going to build throughout this class, and we're going to run into a couple of interesting problems. And let me get out my notes here just so that I am not forgetting anything. So that looks good. So yeah, any questions? If we have time, so we'll do this in Swift UI first, and then if we have time today, we'll start rebuilding some of this with UIKit also, just so that you guys have the ability to use both of those UI frameworks. But we might not be able to finish that all the way, so I will finish that at home and then upload a finished project there if we don't get there. But we'll make sure that we'll talk about the majority of the things that we're going to see here, and then very likely we won't cover this picker here in our UIKit version quite yet. So that we'll see a little bit later. But yeah, so let's start a project. And we're going to create, so we'll call it tip calculator. There we go. We're not going to add any tests for now, just to keep it a little bit cleaner. We're not going to store anything on our phone this time around, so we'll just turn all of those off. All right. So let's kind of just put those view components on there that we saw. Let's make sure that our canvas is working. Why is it not? Oh, we have the Mac selected. Let's pick the iPhone Pro. So yeah, just review of things that we've covered already. Up here, you can pick which device we should simulate or build. And then we should be able to see, why are the previews not showing up? Oh, it looks like something is preparing. I did update to Xcode 18, or 16? 16, so maybe it has something to do with that. It looks like there's a little indicator there that something's still happening. We don't need the preview yet, or at all, really, but so yeah, let's build that UI first that we want it to have here. So let's take a look. So we want something to enter a text amount, or sorry, we want the user to be able to input something from their keyboard. So where do we find that? So up here we have our view picker, and then so we can start filtering. So if I type in text. So we have text field here, down here. So we've already seen text. So that's just a way to display a string to the user. We have text editor. So this is a full-fledged text editor that can display different fonts, multiple lines of text. You can have colors. So yeah, this is a pretty involved UI component, so very powerful. But so yeah, we're going to use the text field, which just has one line of text that we can enter. So we'll drag that one on here. So we have a text field. Oh, now we have the we have our preview rendering. That's great. Okay, so we are going to, so we have the text field. The user can input something. Since we're going to have multiple view components here, so we're going to create a VStack. So a VStack is a container where we can vertically stack our views. So let's add a VStack. So we can put some other components in there. And so there's some placeholder text here that we'll take a look at in a bit here. Let's just put a couple more things on here. For now, let's just display. Yeah, say again. Sorry. To this screen. Yeah. Sorry, can you say it a little bit louder? So, very good question. If I hold down Command, the cursor turns into a little hand icon, and we can inspect. So both of these. So we'll go there. We'll know the answer in a second here. So both of these are views. So as is our content view. So knowing that both of these are views, what do you guys think? What are they? Structs? Are they classes in SwiftUI? Any? Say again. So any other thoughts? So SwiftUI, all of the views were structs. So all of the views are immutable, and we have to go through some hoops to make them accept something that can change a value. And so let's take a look. So I'm holding down Command. I'm going to click on text field, and so I can. This is the definition of the class. Here's the initializer. We often so I guess since we clicked on the class being initialized, it gives us both of these. So let's go to the definition, and once that loads, so we have a struct. So text field is a struct, as it should be, since it's a view in SwiftUI. And then VStack, let's take a look, is also a struct. So all of these view components that we're going to throw on here are structs. Maybe let me see if I'm anticipating where your question was going. A text field has to have something where we're entering something. So we have to be able to change something in there. Is that where your question potentially was going? Yeah. Yes. So yeah, we'll take a look at how that works in a second. Very good. So maybe just for now, so we're going to throw maybe the output label here, so that we'll have the text field, we'll have the output label, and we're just going to couple the two, so that when we're typing something in, we also want this to update. So we have a way to see what's going on here. So let's put a text then below. Again, so I'm just typing it in. If you're not remembering the view components names, again, you can just go up on this little plus icon, start scrolling, or in this case, I know what it's called, text. So let's drag that underneath. And so let's see, how can we, so we have our placeholder, it says placeholder there, we have placeholder there, so that those seem to be related. Also, we're in live mode. I'm going to click the button in the center, which allows me to highlight components on here that will highlight the code as well. So if I click here, the text field gets highlighted. If I click here, the text is highlighted. So there's maybe already a couple of unexpected things that we are seeing here. So one, to me, this doesn't look like a text field. So I wouldn't, as a user, wouldn't know that I can place that I can put some text here, especially if it's not highlighted like this. So how can we, first of all, maybe make this look a little bit more like a text field? So we can add what's called a view wrapper. So let's add a view wrapper, and we'll talk about what that means. So we can add a view wrapper. So we have the creation of this text field. We're adding a view wrapper by just adding the period, and then in this case we want the text field style. And so this might be some interesting or novel syntax that I'm about to do here. We'll explore this probably next week. So I'm going to hit the period, and then I get a couple of options here. So I'm going to say just rounded border, which is what text fields in on the iPhone often look like. So we'll pass through this in a second here. We're going to add another view wrapper here. So we're going to add and we've seen this one already. So let's add padding just to show what's going on here with this text field. This padding view wrapper I could have also added by selecting the text field and then going to the rightmost option here on my property editor and padding down here. So I could have selected this. We can select padding to be just on one of these sides or above below. So I could have also used this editor here. All right, so looks like a text field or a little bit more like a text field. So I think one other thing that we might expect is for these components to kind of start at the top. We've seen this before, I believe we've seen this before with our very first little app that we created. So we're inside a view stack. So the view stack will just take up, so if I have this highlighted right now, so all of the vertically placed views will just take up as much space as they need to. And then the view stack itself will take up about the space that its component that it contains will take up. A good way to visualize this, we can add another view wrapper, and we'll get to what these view wrappers are and what they do. We can say background, and I am having a really hard time typing today for some reason. Let's try that again. There we go. And I can say, so it doesn't have to be a color. You can have other backgrounds. But one of the very quick ways that we can add a background is by just using a color. So maybe I'll say orange, and then, so we'll see that so this is a view modifier, a view wrapper for the VStack. So we modified somehow this VStack, and we said it should be orange, and we could even say we want the opacity, so how much it lets what's behind it bleed through. We can set an opacity, and let's maybe say 30%, just so that it's not quite as brightly orange in our face. So yeah, so we have the VStack, we have the text field in it, we have the text in it, and by default, the text field the VStack will just take up as much space as is in it. And by default, everything will just be thrown into the center of the screen, which is maybe also unexpected. I think maybe you're used to things just, if not defined, showing up at the top. So how do we move these components to the top here? How do we make that happen? So we've seen this before in our very first app. In our VStack, we can just say, hey, put something in here that takes up a lot of space. And we saw the spacer component, or the spacer view, and the spacer will just take up as much space as it can, so to push everything above. And we saw this last week as well, or I think maybe even in the first week. If we put a spacer on top, we end up with the thing that we had before. The two spacers will split the difference here, so they will take up equal amount of space. If we put another one in between, it'll be a three-way division here between those components. And so one thing we're seeing here is nowhere really am I saying, oh, this component should be 5 pixels from the left or 5 pixels from the center. Why do you guys think that is happening? What is the benefit of not doing that? Yeah.
Like different devices can have different.
Very good. Yeah, different devices can have different like widths, all of that. So everything that we've done so far, and also device orientations. So everything we've done so far, we don't really care what device we're building to. And like a good way to show that is we can just, I have the iPad here as well. It might take a little bit of time for this to show up. So I now picked the iPad. Now the preview will update and show an iPad, it'll make sense of this, and it'll mostly, so most things that you do will have a pretty good default way of looking without you having to say on an iPad or on a device with this size, do this. So this is still taking a while since it's the first time we're launching it. Yeah, so it's a really neat way to write something once, and it kind of works across the board. And then, especially if you're going from iPhone to iPad, maybe you want to make a couple of modifications, but you can just focus on one first and then kind of tweak as you go. So this is taking a long time. Not sure if it's worth waiting. We'll see. But yeah, so if this were to update, we'll have a big iPad. Kind of looks the same way. Here we go. So it kind of looks what I would expect this to look when it's scaled up. And then let's remove those additional spaces there, just so it goes to the top. And so hopefully this time it should go much faster. Here we go. So it just popped up to the top. So I would say if I had an iPad app that did this, it's workable, but I think those like really long text fields are a little awkward. So maybe we would maybe have a slightly different view for the iPad, but we don't have to. Like it kind of just works on all devices, which is nice. So let's go back to I think we had the iPhone 16 Pro here. Let's go back to that. All right, so yeah, VStacks, we've seen them, I think, in the very first lecture. We can throw views inside. They will kind of just organize themselves vertically, and then if we need to push things somewhere, we can say, hey, add this spacer. The spacers by default take up as much space as you're saying, but you can also say, hey, you should take up a specific amount of maybe height. So we could say frame, and then height, and then let's say 200. And then so you see again, the VStack only takes up as much space as the components inside. So we have a text field, the text, and a spacer that is 200 tall. All right, any questions here? Cool, okay, so let's get rid of some of these placeholder things here. So text field, by default, we have two things that we have to pass in. One is what they're calling placeholder, which is what shows up when no text is in it. So no text in it when it's not highlighted. So once you select it and you have a cursor there for typing, this text will disappear. So what might be a good placeholder text for our tip calculator? Let's see. So what should it say? What would you expect an empty text field to say, where you're supposed to type in the value of your meal? Yeah, so here we would put in so maybe let's go through these components. So I would put the value of the meal here. We can select the tip. When we're hitting calculate, it shows us the tip amount. So what would be a good thing for this to say? Input meal amount, yeah. So let's say, I think I'm mostly seeing not like prompts necessarily in these. It's often just like a description of the thing. So let's maybe say amount. Okay, or total amount, or meal amount. Yeah, maybe meal amount. Great. All right, and then so here the placeholder. So as we know, we've seen this. Have we seen this? Maybe we haven't seen it yet. So I'll just double click. If I double click, it lets me edit it. And let's say total, and then it'll eventually say the total here. All right. So now let's take a look at the second parameter that we're passing into this text field initializer. So and maybe let's maybe build this real quick. I'm going to do Command R, or you can just click up here. We're going to build this, and then we have it in our simulator, and then we can maybe just really briefly demonstrate that how that placeholder there behaves. So simulator coming up. Okay, that's not turning. That's concerning. Oh, has to reboot. That's not great. Okay, well, we'll have that think about what it did there, and we'll come back to it. Okay, so I find the parameter so the parameter name here a little bit misleading. So we have the text field, and it's saying text, I guess. And we'll talk about why maybe you find it properly named, or maybe not. We'll see here. So let's maybe see what so again, I'm going to command click this, and it'll get, so this time I don't want to go to the definition of text field. I want to go to the initializer that I just also command clicked, because I clicked on the type with the initializer, with the properties that are being passed in. So let's click there. Let's see what we have here. So we have our text field, we have an initializer. So there's already an interesting thing here, localized string key. We can just ignore that, and we can just pretend it says string. We passed in a string, so let's say it says string. And then for text, it says binding and string. I'm going to be inputting numbers, so as we're putting in the text amount. So that's good to know that those numbers will be represented as strings. But then the other thing that's maybe a little bit confusing is this binding and those pointy brackets there. We have seen this syntax before, where we have a type, and then we have those brackets. Does anyone remember where we've seen this before? Yeah. Generics. So who remembers what generics were? So or what context did we see them in? Yeah. Maybe, hold on one second. Maybe anyone else? Okay, so where have we seen them?
So it was basically like a thing that can accept any type.
Yes.
It could be anything from an object to like an integer, a string.
Yeah, very good. Yeah.
So like anything generic, basically.
Very good. Yeah, and then so yeah, so we had it in the context of a box, I think. So we said if we said this is an integer box, what did that mean for that box? So so here this says it's a string binding. Let's just replace it with a let's say maybe this just says box. So string box. What can we put inside this box? Strings. Okay. If it says integer box, what can we put in it? Integers. So yeah, we can't, once we declare what kind of a box we have, we can't put anything else in it. So we can't declare a string box and then put doubles in it. And it makes it so we don't have to create a box for integers, a box for doubles, a box for strings. We can create a generic box where once we say what kind of a box it is defined what kind of a box it is, but we have the option of deciding what it is as we're creating it. So another generic type is in Swift is the array, for example. So we can have an array of integers, an array of strings, and we can say that we can see that in a little bit here as well. But yeah, so very good, generics. So we are supposed to put in something that is a binding, a string binding. So we'll see what that means here in a second. So how would we do that? And this is now loaded, so we can see if I select the first time you're interacting sometimes with the simulator. Oh, okay. So I was wrong. So once you have the cursor, you can still see it, but then once you start typing, this is being very slow today. Let's see. So yeah, once you start typing, that placeholder goes away. So one other thing I can use if I'm interacting with the simulator, I can use my keyboard. Once I do that, the software keyboard goes away. The keyboard that I have on the computer is actually, it simulates a Bluetooth keyboard. So I could have to any of the iPhone or iPad, I could connect a Bluetooth keyboard and it would behave the same way. If I want it back, so I always forget exactly where it is. I go to help and I type in toggle, and then so toggle software keyboard. So that's what brings it back. So I guess input output keyboard toggle software keyboard, and then this thing comes back up. You can type, and then once you use your actual keyboard, that thing goes away. Just something to keep in mind. So it's much easier to type in with your keyboard, but then one thing that you're not getting is probably most users' experience who are going to use the software keyboard. And there's one other little thing that we'll run into if we are that we'll see that is a consequence of this. So we'll see that in a bit here. All right. Say it again. With this thing, does it push? So this is a one-line text field. So here we will just start scrolling. Oh, okay. Yes. Yeah. So yeah, we want to design for, we want to be able to see what's going on there behind the keyboard, or maybe it should be pushed up. So we'll see all of that in a little bit. Not today, because we won't have too many components, but very good question. All right, so we have a text field. It says something string should be passed in. So let's see if we pass in a string. So one simplest thing I can pass in is maybe just an empty string. So let's see what the compiler says. So we can't convert a string to a binding string. Okay. Then next thing I could try is so the declarative ways of writing the UI in Swift UI might suggest I could create a string out here. Maybe we'll call it amount or meal amount. Let's have it be a string. Let's have it be an empty string at first, because we have to, in Swift, every type has to be has to have something in it. Any variable, any property has to have something in it when we're instantiating our struct here. So maybe can we put in this meal amount here? Let's see what happens. And again, so we have string to cannot be cast to a binding. Okay. So what other tools do we have? So if we have a button and we want it to, so we're trying to modify, so whatever is in here, this text field's text, when we're typing, that should update, right? So whatever the text we're typing in, we somehow want to get. What did we use? So we can't, so first of all, we can't put a string in here, it sounds like, but then also if the text field were to update the meal amount, what issue would we be running into? So let's comment this text field out again. Let's do kind of the same thing we've done in our first lecture. Let's put a button. Oh, apparently today's P's and B's are switched in my head. Let's do a button. Let's say enter or set meal amount, and then this will just set the amount to 100. Okay, so this we've seen something very similar here. We wanted to update a variable with a button, and then now we get that familiar cannot assign property self. Cannot assign property self is immutable. So what is going on here? Yes. Yes, very good. And if we were to change something, which through like some so what would we get if we were to change something about the struct? So if we are if you have a 7 and you're updating it to be an 8, so those are also value types. what would you get? You would get a new instance, right? You wouldn't have the initial one. So if we were to change something about it, we would get a different one. So yeah, we can't update meal amount right now.
Is that the rebuild process, which is it's creating an instance of this?
We would be creating a new instance if we were changing this one. Yes, exactly. So we would be rebuilding the struct the same way, but with this property changed. Very good. We had talked about that, yeah. So in SwiftUI, what were we doing to our types if we wanted to carve out a little area there where we can change the view's state? Like in this case, we have the meal amount, which could be described as the view's state. So what could we do? Add state, very good. So we have something that describes the view's state. So let's add the state property wrapper here. So the all of the errors, the compile time errors went away. So let's make it so that our text field here now updates as well. So let's say we want our total to be displayed. There's a lot of ways that so let's say we want to say total and then just the meal amount. So we're not calculating anything yet. Lots of ways we can build strings. So one way I could say plus and then the other string that I want to display. So we could do this. Or often you have a string on the inside of another string. So maybe we have something behind it. Let's just add someone is so excited about it, we'll add some exclamation points. So what if we want the meal amount to be right there? So then we can't use, or not as easily use this. We can kind of inject our string into another string. How do we do that? With a backslash and then brackets, and then we can add a variable. So we are escaping, there's a way to escape the string, or we're able to put another variable in here. So you'll see this a lot. So you want to build a string out of two strings. One of them is contained in the other one. So the backslash and then the brackets does that. Any questions here? So yeah, I think in Java you have to use like a string builder object, if I'm not mistaken. Is that right? Or maybe that's old Java. Anyways, very nice, very easy way to build strings. Let's see if our preview. Oh, I guess we want to interact with it. We could also do that in the preview, but let's just build it again and see it in the simulator. So yeah, our state, our meal amount is now a state. We can set the amount, and it injects the 100 in there. So we can now change the meal amount from inside our view, which is great. Okay, so little bonus question here. Our orange background looks different. Who can figure out what happened? Totally fine if you can't. What happened? Very good. Yeah, so text fields take up the entire width of the screen, as you said. Buttons do not. Buttons just take up as much space as they want, as you want. So yeah, that's why that background is like that. So we're going to see other ways to do this, but like one way we could do this is by adding an H stack. So V stack, vertical stack, H stack, horizontal stack, and then we can add spacers. And I guess now we can also use our canvas here. So this would push the button all the way to the left. If we want it in the center, we can do that. There's some other ways to do this, but with the tools that we have right now, that's how we would have the background of our initial V stack take up the entire amount again. Okay, so we have button. So we have now a way that we can manipulate the string variable. So how do we manipulate, so how do we extract whatever the text field does here and save it somewhere? So I guess I'm hinting already at wanting to save it in a variable that's in our content view here. So let's see how we do that. Let's get rid of the button. Let's bring our text field back. And so we did try just putting the meal amount in when it was a string. So we can't put a state meal amount in there apparently. The reason for that is wherever we're using this amount, this meal amount, we are treating it just like a string. So for any view component that needs a string, it just looks like a string. It doesn't look like whatever is done to the string, so that we can change it inside our struct. So we're just seeing the type that we've declared here. Okay, so other things we could do. This is a property wrapper. We'll see those later. So state, add state is a property wrapper, which means it wraps our string with something else. In this case, with this magical box that updates our view if we update what's inside. So there's a way to get to the actual box so the thing that wraps our meal amount here, or in our string. So let's try that. Let's put that in there. We can get to the actual box, or the actual thing that we're wrapping, or the thing that is wrapping it, by doing underscore. So this gets us, and this is I think the only place where underscore doesn't mean something is omitted. So so underscore gets us, and now we have a type that would be this. Oh, state string. So that's what we have now. So that's what we have access to. We have access to this magical box with the underscore. Let's see if the compiler likes that. Nope. Let's see what the error is there. So we can't convert state string to binding string, but we're getting closer. So those kind of look more similar. So wanting to pass these magical boxes into other views is a very common thing. So there's a very convenient way to write that. So instead of underscore, we can say $. And now the state gets turned into a binding. So we wanted a binding. We had a state. We wanted a binding. So the $, turns any state property into the equivalent binding. So here we have a string binding. What is a binding? We'll get there. So we'll, I think, continue a little bit here. But yeah. So how do we make this work for now? We have a state state annotated property that is a string, and we say @ and then the name of this variable, and that's what the text field needs. So for that reason, I'm finding the text label here a little bit misleading. To me, I would think maybe I'm passing in an actual string, but yeah. So we want to pass in a string binding. Again, we'll go over what that means in a second. Say it again. We still need to add state. Yes. So let's build this. Let's see what happens. So yeah, this. Yeah, we'll go over. I'll revisit your question in a second. All right, let's see what this does. So I was able to build. All of the compile time errors went away. And let's type in a meal amount here. So let's start typing. And as I type, our text field updates. This might, so to many of you, this should seem strange. Maybe in the back of your mind, you're still, you're thinking, okay, it's kind of similar to the button updating this thing, and then it just magically updates. But like, it is a very disconcerting thing to many. So you're just You're just updating a string, and then something updates on the screen. So this is inherently something that will happen in a declarative programming environment. You're just saying a variable has updated, and then the UI just does without you telling it to. What you're probably more used to would be you're updating a property, and then you're saying view or label refresh or something like that. So that's probably something that you're a little bit more used to. I'm assuming, and that's the other. So yeah, we're in a declarative programming environment, and then imperative programming is when you're describing how something should happen. Here we're just describing what the end result should be. We're saying meal amount should say whatever I just typed in, and then the view renders with whatever I said, without me having to tell it that it should do that. So to whom is this still pretty like magical and like weird, or maybe, so who thinks it's not weird? Who thinks it's not weird? Okay, so either all of you guys are very shy or doing something else, or yeah, anyways. So I find it still strange, but yeah, it's a really cool way to write UIs. All right, so we have a way to update our text here. So let's maybe a little bit, yeah, let's go back to what we're actually doing here. So we have, and let's maybe go back to our iPad here. So this is our, so I guess here we called it content view. Let's maybe rename this. Let's rename this tip calculator view. So how would I rename this? I can right click, refactor, rename, and it updates it everywhere where it needs to. So in 3 places, the name of the struct, in our preview, which generates our canvas, and then also here. So in our calculator app, there's another place to update it. So if we, and then the name of the file as well. So if I right click, refactor, rename, I can take care of all of that in one place, and let's maybe call it tip calculator view. Okay, so our tip calculator view has in it a VStack, and then inside the VStack is the text field. So let's just say we're making it slightly simpler. The tip calculator view has a text field inside it. And so the tip calculator view has the meal amount property. So what is happening here is we don't have a property on our text field that says this is the thing that we're changing. So that just doesn't exist. So somehow we have to, so if we're looking inside, so let's say we're looking inside the text field. So if this is the text field, so we actually can't look inside because it's not accessible to us how it works. But the text field would have this, so they're calling a text property here. And when the user types, this text is updated with a string. And then somehow, yeah. Oh, sorry. Yeah, thank you. So we have this text field. We can't look inside, but like what's happening inside is somehow there's a text property that is somehow a string, and as we're typing, it gets updated. So that's likely what's inside. So how do we communicate this updated property, how do we communicate that outside of the view? So the way that it's solved here is, so we have our state property, and we said it's this magical box that updates our view and lets us know when something has changed. So what the binding allows us to do is to take one of those special boxes, pass them into another view, and then that view can write to that special box without having to initialize it. So we're just getting the special box. We don't have to give it a default value. And as we're writing to it, not only does our view update, so the text field itself updates, but it also lets the containing view know that something has changed. So in this case, we're taking the special little magical box, we're handing it to text field. Text field makes a change, updates, the text field itself gets updated, the user's typing shows up, but also the outside view is notified. So since it's the special box, we know that something has changed. So what a binding is a way to take the state that was defined somewhere outside of our scope. So some parent decided, some parent owns the state, and then a binding is a way to pass that state into a child view. And then if the child view updates it, the parent view will know about it. Does that make sense? Okay. So yeah, that's, yeah. Yeah, I mean, like, yeah, so what's going on behind the scenes, we will talk about that so at the very end of the course. So some events are passed, yes, so there's something gets notified. We will see exactly how it works. So what's behind here is, yeah, events, I guess, events, what language are you talking? Or also fine if you don't have anything, but yeah, so what's going on in the background here is, and maybe I'll give it a little preview here. So we have a way to have the special variable that we can subscribe to. So we can say, hey, if you update, I want to know about it. So it's a little bit more powerful than, we'll see this also. So you could pass in, maybe some of you guys have heard of passing in functions as arguments to then execute when something happens. Don't worry if that doesn't ring a bell. But so there, only one place can get updated. Here, as many subscribers as they want can subscribe to these changes of this magical box, which is pretty neat. We'll cover it later in the course, and we'll know exactly what happens behind the scenes. Yeah. So if I'm understanding you correctly, so let me just restate what I'm saying and then see if that answers your question. So tip calculator view has internal state. So it has something that describes what it looks like, what it behaves like, what it contains. So it has some state. So tip calculator owns the state. So tip calculator owns the meal amount. And then we can pass this magical box in the form of a binding into another view. So this text field doesn't own the state. The outside view owns the state. So a binding is a way for state that is owned by a parent view to be modified by a child view. So if you're thinking of, so it's a very so if we're looking at, like, so yeah, it'll always be the parent who owns something if you're dealing with a binding. Does that answer the question?
Yeah, so you can
Okay.
have a situation where like twins looking back and then you want to pass a binding, so like all the
So yeah, you would be passing the binding down. So you would be passing it into all of those children, so that like so here you would pass it into another one. I mean, we could have a maybe tip calculator. I don't know, some like a bigger app that hosts our tip calculator that maybe is now supposed to own the tip amount. So we would be passing that in as a binding to our calculator view, which we would be passing it into this. So yes, you can have that, but then you're linking all of these things together, like very tightly. You're tightly coupling them. So there are some other clever ways that we can work with that. You'll see them, and maybe the hint that I'm giving here, or like so there's a view environment. So we can place things into the environment, and then all of these so child views can take things out of the environment. So it's again a very clever way to do it. We don't have to tightly couple all of our components. We can just say, here's a thing for anyone who's interested, and then way down, someone can say, oh, I want that. So we don't have to pass it down. I find it very clever. But yeah, very good question. So we don't want to pass something down 20 things, because it gets like very rigid. We won't be able to modify things very easily. Okay, so I'm also seeing we're kind of coming up on a break here, so I'll stop at a good amount here in a second. So yeah, maybe I'll just recap and then we'll do a break. So states, again, are these magical boxes inside our views that allow us to even modify the views. That if whatever is modified there, we get our view to get to be redrawn. If we want to have another, if we want a child view to modify our state, we can pass it as a binding into that child view. Because that happens so many times, so often, we have this like $sign syntax, where any state, if we do $, we get to the binding representation of that state. And then, so maybe just real quick here, you're maybe wondering, why can't I just pass the state in? So I'm just gonna create a struct here real quick. I really can't type today. Let's say we'll just create a what do we call this? Maybe just another box. We'll just create another box here, which will be a view. And then, so this thing is not supposed to, so this thing will take a binding and not a state. And maybe it'll be text again. And then or maybe we'll call it display. Here we go. Okay, hopefully everything goes away. So if we have a display view where we are maybe styling our text neatly or whatever, we don't know what we're gonna. We know we're gonna display some sort of a string. We don't know what that string should be, so it really doesn't make any sense really to have a default value here. So we're not creating, we're just manipulating the thing that we're going to we're not manipulating this thing we're displaying, we're just displaying it. So this is what, so same thing with the text field here. We don't own the meal amount. We shouldn't have a default value for it. All we care about is that it'll get passed to us as a binding, and then we can display it, we can manipulate it, but we don't own the state. The state lives somewhere else. So that is why we're not passing in state. We don't want to be able to have a default value here. We just want to take the magical box that we're given. We don't want to create our own magical box. So and then yeah, I mean, we can just have this display. also show our text here, which now we should have two things rendering our amount. Here, let me just build that real quick. And then, yeah, so the cool thing is, since we're passing in this magical box, our display also knows when it updated. Our text, we could change the text inside because we're given the magical box in the form of a binding. We could also now change it, and it would change on the outside. Yeah. Here's we don't have a so this, the binding means we don't own this. So state, we own this. We have to give it a default property, so here we don't own it. It's this magical thing that will update. Does that make sense?
Yeah, but can't you state this way, with immediate, like if we pass it on a state, I still just passing the
Okay, I see. Why not just pass in the state thing? Fair question. Yeah, I guess that would be possible, but since we have a binding, so it allows us to do something else neat. So we could have a computed binding. So we could take, and I can show you what that looks like. Again, we'll see this later. So here, what we have, and it's doing some really weird stuff, formatting. So yeah, so we're not passing in a state, but we could return however we're creating this thing. So we can kind of create our binding from multiple places. We don't have to. Maybe we don't have it in a neat state way here. Maybe we're getting it from somewhere else. So we can have we can kind of assemble what we're passing in there. So there's a little bit more flexibility here. Yeah, so you're asking why can't we just pass in the state thing? So there's one. Yeah, it's ownership, and then so I guess so also behind the scenes. So this is a struct, and I'm not 100% sure how that actually works. So you can also have property wrappers that are classes. So maybe the actual answer is the state wrapper is a struct, even though I said we're carving out this magical space that is a value type. Behind the scenes, there's still something that has a value type associated with it, even though this is a struct. So I think the short answer is state is a struct. We wouldn't be able to modify it that way. But I'm not 100% sure. I guess is also so one reason is we have more options by passing in a computed binding. So that's, I guess, one answer. And are there other benefits? Yeah, it's not just not done. I don't think you. There's something else. Yes. So maybe this is it. A very good question. So state only. So if you have nested views, and one of them, so like at a couple of levels deep in, the outside won't know about it anymore. So I think another answer might be the binding guarantees that every place that uses it knows that it gets updated. So there's like some very edge cases where if you nest it very deep, state will not trigger an update. But yeah, I guess I don't know 100%, but yeah, the answer is. But there's a couple of thoughts that I have. But yeah, not 100% sure. Very good question. All right. So yeah, but to recap, we have the magical boxes. If we want to pass them into other view components, we have to jump through the hoop of passing in them as bindings, and then we can update state that is owned by a parent inside a child. Any questions there? And I will think about a little bit more what you said maybe tonight. All right, then let's do a break. Let's come back at 8:20. And then I'm going to try to do add codes now. So